Hello. Hi, Maya. All right, so we are going slightly out of order with this unit. This lesson just made sense to come first before what we're going to do on Wednesday. So sorry for the confusion on that. So this is really the first lesson we are doing. First lesson for Unit 8. So whatever. I don't know. I just didn't change the title, so deal with it. It's fine. All right, so imaginary numbers. You might be thinking, that sounds weird. Imaginary is made up. It's like a unicorn, which they still really haven't proved that doesn't exist. I mean, a narwhal is like the unicorn of the seas, so I feel like it's not that far of a stretch. Anyway, so let's just review. If I'm going to solve these equations for x, hold on, let me get on the right page here. There we go. All right. So if I want to undo a square, what do? We square root it. So we get x is equal to plus or minus 5. So nothing too earth-shattering there. We've done it before. Similarly, if I go to the middle one, I just get to start to get x alone. So I'm going to add 12. So we get x squared equals 12. We do the same thing. We're going to square root it. This one's a little bit more exciting because 12 is not a perfect square. So if you wanted to break it up, it's really like 12 equals 4 times 3. So square root of 4 is 2. So we really get plus or minus 2 radical 3. So a little bit of review from a past unit. And then the last one, we would have to add 33 over first. Then we'd have to divide by 3. And then we would still square root. Now this one doesn't come out pretty, so we're just going to leave it as the radical. So nothing new there. We've been doing that for a pretty long time, a few years now. Okay. So I was about to scroll on the wrong screen. Haha. Okay. So exercise 1. On the axis below, sketch y equals x squared. Or on the axis below, a sketch y equals x squared is not shown. But as we know, it's just the parent function. So I will sketch it in. Now it's there. Yay. Okay. So if the parabola is shifted up 1 unit, what would the new equation be? Well, that's what we just did in the past couple weeks. So if I want to just make it go up 1, it's just literally going to shift up. The width is not going to change. But now it's going to be y equals x squared plus 1. Just going up 1. So pretty much the same. Little different. Just shift it up. Okay. What can we say? Oh, I want to change colors. So let's do pink. What can we say about the x-intercepts? If we remember the x-intercepts of the new function, so the x-intercepts of the red one, that's when your y equals 0. And that's like your roots. So remember, that's like your roots. They're also called zeros. They're also called solutions. Remember, there's like a million names for the same thing, right? So if we look, that parabola doesn't go through the x-axis. The x-axis. So no real roots exist. It does not cross that x-axis. There's no roots. The original one there was. But for this one, it's just floating above. So no, there's not. All right. So it says algebraically, show that these intercepts do not exist in the real number system by solving the equation from part A. So if I'm going to take x squared plus 1. Oops. Getting all messy. There we go. And set it equal to 0, just like we did in that top section. I'm going to subtract 1. And then I'm going to square root it. So plus or minus radical negative 1. So you're like, can't take the square root of a negative yet. So as of right now, that's what we have. It does not exist. So hence this new thing called an imaginary number. So fun. All right, since we cannot solve this equation using real numbers, we introduced a new real number called I. And it's an I. It's got like a little hook on the bottom, so like the opposite of a J. The basis of imaginary numbers. its definition allows us to now have a result when finding the square root of a negative number. So, let me highlight this too. So if you have the square root of -1, it really equals I, or 1I. But we don't write the 1 because we're lazy, right? So, simplify each of these. If I was going to break it down, this really would look like the radical -1 times radical 9. I'm allowed to break it up, right? Nothing illegal about that. We know now that the square root of -1 is I. You notice I put a little hook on the bottom. And that's times the square root of 9 is 3, technically plus or minus for both of these. Actually, I is just going to be I. I want my eraser. Excuse me. So if I put that together, I get plus or minus 3I. So that's how that breakdown goes. So similarly, if I'm going to do that for a square root of -100, I'm going to have the square root of -1 times the square root of 100. We know the square root of 100 is just plus or minus 10. Square root of -1 is I. Oops, forgot my little hook down there. So therefore, we have plus or minus 10I. So nothing too earth-shattering. It's almost the same thing that you've been used to be doing. So let's do one that's a little bit more exciting because, you know, perfect squares can get boring. So 32. I'm going to break this up with the square root of I. Oh, I'm getting ahead of myself. Not the square root of I. Silly Sadler. Square root of -1. And then we have the square root of 32. Technically, my program went away. Plus or minus. So 32 is not a perfect square, but if we think about 32, let's do it over here. If I want to, oh, that's a very bright green. Wow. Okay. That's better. We have 16 and 2. Or you can break it down to the product of primes, whatever way you like doing it better. But it's really a radical 16 and radical 2. I break it up like that, which I think is the way most of you were used to doing it last year with Miss Halton, or 2 years ago, whenever you took it. So we have our I here, times plus or minus. The square root of 16 is 4. And then that radical 2 is not going to simplify. My computer froze. That's super fun. Radical 2, so I'm just going to put that all together. So we get plus or minus 4I radical 2. So this section right here, you are going to have your homework questions and Delta Math on it. So this section, if you want to like put a little star next to, you're going to be expected to know how to do this on your homework. Let's do one more example. Radical 18. So we have square root of -1, square root of 18. Obviously, we're going to have a plus or minus in front of that. We can break up 18 off to the side if that's helpful. So we have 9 and 2. And again, these are radicals. So we have I over here times plus or minus the square root of 9 is 3. And we're going to keep our radical 2. So putting that all together is 3I radical 2. Now, some of these you might be like, Miss Sadler, I can do them in my head. And that's great. If you don't want to show all these steps, I'm not going to force you. Whatever works for you. If you know how to do it, you know, I'm pretty content. So let's try some where we mix what we did in that warm-up up top with this new process that we just learned. So I'm going to skip A because it's a little bit boring. So let's go to B in the next section. So if I want to solve to get x alone, I'm first going to have to subtract 20. So what do we get? -18. And then I got to get rid of that half, so I'm going to multiply each side by 2. And then I've got to undo the square, so I'm going to square root it. And then since 36 we know is a perfect square, that's just 6. And since we see that negative, I can really just go into saying x equals plus or minus 6i. But if you want to show the additional steps like we did above, you're more than welcome to. I'm just not going to because that one was pretty chill. So definitely going to want to know how to do that. Let's try another. All right, so similar to example B, I'm going to add 10 over. Oh, excuse me. That was getting odd. Kind of did. All right, then we're going to have to divide by 2. And then we're going to have to take the square root. And I'm not going to just leave it as plus or minus radical negative 13. I'm going to take out that I. So it's going to be plus or minus I radical 13. So make sure you go one step farther to pull out the I. Okay? So now that we know what an I is, what an imaginary number is, let's get a little bit more deeper with it. Questions so far? You good, Maya? I feel like I'm going kind of fast, but no one has slowed me down yet. So, are we good? I wonder if I still have my guinea pig gift down here. I do still have Blanche. Isn't she cute? All right. So, what would be equivalent to 5i times 6i? So this is going to be very similar if I would have asked you what is, thank you, Maya, 5x times 6x. So let's kind of write that here. 5x times 6x, you would say 30x squared, right? Nothing too earth-shattering there. It's going to be a similar process for this. We are going to get 30i squared. Okay, so, but what is I squared equivalent to? Well, if we kind of go backwards there, we said the square root of negative 1 equals I, right? So what this literally translates to is 30 times the square root of negative 1 squared. Because remember, radical negative 1 equals I. So I just have 2 of them, so I'm squaring it, right? So, oh, excuse me. What I'm left with, hold on, move this microphone just a pinch. If I have a square and a square root, what happens? They cancel each other out, right? So I'm really left with 30 times negative 1, which equals negative 30. So right here, let me pick a different highlighter color. There we go. So the square and the radical cancel each other out, so you're just left with what is on the inside. So we got negative 30. So this is going to lead us into a pattern of i's. So powers of I display a pattern that allow us to simplify large powers of I into 4 cases. Super important. So we're going to look at I to the first, I to the second, I to the third, and I to the fourth. These are the 4 main cases. And it's these 4 that I'm going to highlight. So these 4 are super important, and we need to remember that I is just equal to the square root of negative 1. Okay? So I to the first power, anything to the first power is just itself, so it's I. I squared, as we saw above, is negative 1. So what's I cubed equal to? I cubed is going to be equal to I squared times I to the first, right? Because when you have the same base and you're multiplying, you add your exponents. So we know I squared is equal to negative 1. And I to the first is just I. So therefore, it equals negative I. So I cubed equals negative I. And then lastly, I to the fourth, that's really like saying I squared times I squared, which is negative 1, times negative 1. So therefore, I to the fourth equals positive 1. So there's an easy way to remember these. And I do want you to write this down. So I to the first, I to the second, I to the third, I to the fourth. And I do want you to write them vertically like this. So how I remember it is I think of I won, negatives in the middle. So just like a little brat of a child screaming, I won! Negatives in the middle. I won, negatives in the middle. I won, negatives in the middle. So these are the 4 main cases that you need to know. Super duper, hardcore important, pretty much the basis of this entire lesson. Comes down to this yellow highlighted piece. So write that down, know it in your soul. Sorry, that sounded a little emo. All right, so if we can break higher exponents into these 4 cases, then we can simplify them. So let's take a look at I to the 6th. I'll change colors. Orange, why not? So I to the 6th, right? Oh, wait, I missed one. Sorry. I to the 5th. Haha. I to the 5th can be broken up into I to the 4th times I to the 1st. And I wonder, I'm going to bring this. Nah, I'll just zoom out, whatever. So I to the 4th, if we look over here, is equal to 1. And I to the 1st is just I. So therefore, it just equals I. I to the 6th is equal to I to the 4th times I squared. So remember, same base, just add your exponents. That's all I'm doing there. I to the 4th we know is 1. I squared, if we don't remember, we can always look back up here at our handy dandy chart, is negative 1. So therefore, I to the 6th is equal to negative 1. It's nothing too shabby, right? So we can do the same thing with I to the 7th. We can do I to the 4th times I cubed. Well, what's I to the 4th? We said I to the 4th is just equal to 1. And I cubed is equal to negative I. So therefore, it equals negative I. So, nothing too shabby. What about I to the 8th? Ah! Oh, how'd the calculator get here? I don't know. Go away, calculator. I don't know. Ah! I don't know how to get rid of it. Oh, there we go. I don't even know how I slid that sucker over. All right. Anyway, sorry. I to the 8th is going to be equal to I to the 4th times I to the 4th. I to the 4th is just equal to 1, and 1 times 1 is just 1. So, nothing too shabby. So, let's do something bigger. I to the 38th. Now, you may have seen some other patterns, or if you want to just keep using the 1, 2, 3, 4, it's totally fine, you know. Whatever works for you. Let's do one a little smaller. It won't be that cruel. Let's do like the 21st power. Let's do like I to the 4th, I to the 4th, I to the 4th, I to the 4th, do I have enough? 4, 8, 16, 20 times I to the 1st, right? 4, 8. Oh, wait, no, I don't have enough. JK. One more. There we go. 4, 8, 12, 16, 20, 21. All right, there we go. Well, all these I to the 4ths, it's really like saying I to the 20th. Oops. Times I to the 1st, because all of those I to the 4ths is just positive 1. So we really just have 1 times I to the 1st power, if we look up there, is just I. Or I guess I to the 1 is just I. So therefore, it equals I. So, hopefully, that lesson wasn't too bad. But again, the basis of what you need is right here. This is messy. I'm going to fix that because it's going to bother me. I to the 1st. Haha, now it's better. Okay. This is the most important part. You need this. I won. Negatives in the middle. That's how my math teacher taught me to remember it. So, your homework tonight is in Delta Math. It is due on Wednesday. And Wednesday, we will actually go back to lesson 1. And don't forget to make sure you do your weekly check-ins with me. You can do your weekly check-ins live with Twitch. If you just comment me like, hey, I'm here, check in. You can do it through email. You can do it through Zoom. So as long as you're just telling me like you're breathing and alive, that'd be great. You know, once a week, and you get a grade for it. So it's like the easiest grade of your life, right? So have a fabulous day, and I'll see you Wednesday.